Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue my series on adapting the fighting fantasy rules to a Twine game using the Sword and Planet subgenre of science fiction to inspire the setting and plot. More specifically, I would like to talk about automated testing. So I've been doing quite a bit of what you might call manual testing, by which I mean running the game and playing it as far as one can play it, which is not very much because it's far from a complete game. Um, and occasionally I found that I haven't set things up properly. It's not going to the right place, or it's generating errors, and I fix those as we go. And that's important. And I need to keep doing that, of course, as I add more material. But I also want to have automated testing where it's not me playing the game. Instead, it is the computer simulating someone playing the game, and simulating that because it's a computer and it can do things very, very quickly. It can simulate running through the game 10 or 20 or 100 times very quickly, and it can keep track of results, and it can give sort of, as it were, the results of 400 plays of the game, which it could do that in probably a few seconds to a few minutes, whereas of course for me to do that would require several hours of my time. Also, of course, I often find that when I'm playtesting games like this, that there's particular choices. I tend to make the same choices at the same points. Sometimes if there's three choices, I might always make the third one in a particular section. And of course, that means that the results of making the first or second choice don't get tested, or at least at least I won't do it as often. I won't do it sort of one third. I won't do those other choices one third of the time, and therefore those other avenues, those other possibilities don't get properly tested at the very least. Whereas a computer, I can just say, well, when you have a choice, choose randomly, and therefore it will sort of tend to choose each choice roughly the same number of times, and therefore everything will get properly tested. So what can this automated testing tell us, and what can't it tell us? Well, I'll start with what it can't tell us. It can't tell us quality stuff. I suppose that's how I'd broadly describe it. It can't assess quality, so it can't look at a text and go, that's a bit awkward. The way that's written doesn't make sense, or the way you've worded this choice and the thing that happens if you click that choice, they don't quite match, or it doesn't quite make sense. Why is this character seem friendly here, and then suddenly they're hostile if you do this? Or why does this thing make them more angry than this thing when it seems like it should be the other way around? These are questions that we need a human to get reliable answers for. I mean, I suppose you could say that ChatGPT can give answers to that sort of thing. AI is kind of getting better at simulating making those sort of judgments, but it's still not very good at it, really, I guess. I mean, it's remarkable that it can do it at all, I think, but I wouldn't rely on it. And you still really need a human. You still need me to be playing the game to make those sort of decisions. But what automated testing can do is it can give us numbers, basically. So we might set it to play 100 simulated games with each of the 4 possible characters that the player can choose, and keep track of how often each type of character dies. So it might do that, and then it might say, well, character 1 died 10 times, character 2 died 15 times, whatever, right? It'll give us numbers. And that is very useful for balance. Generally, in games like this, and certainly in my case, in this particular game, you want the different character options to be about as good as each other. They don't have to be perfectly as good, but I don't want a character where if you choose it, you're just going to lose. And I don't want a character where if you choose it, you're just going to win, right? I want them to be roughly that they're going to live or die roughly the same percentage of the time. And I also have a difficulty in mind. So it might say, well, it might be that the program tells me, well, they've all gotten through sort of 13 to 15% of the time. And I might say, well, that's great for balance. That's not a very realistic number, by the way. I suspect that the vast majority of characters will get through what has been written so far, because it's not intended to be all that deadly thus far. But when the game is finished, overall, it may be that deadly. So it might tell me, okay, character 1 got through 13 times, character 2 got through 14 times, character 3 got through 13 times, and character 4 got through 15 times. And I would say, well, that's great. In terms of balance, that seems about right. They're all getting through it roughly they're all getting through it roughly similar amounts. There's no super character and there's no doomed character. But I didn't want them to get through 13 to 15% of the time. I wanted them to get through whatever, 30% of the time, or 5% of the time, or whatever it might be. Depending on, I would probably tend towards perhaps the harder end of the scale, but it doesn't matter. It's whatever you decide in your game. And so we might conclude that instead of adjusting it so that one character has an easier time of it and another has a harder time, we need to adjust it so that everyone has an easier time or everyone has a harder time. The other thing we can keep track of is where the player ends up. So we might say, it might tell us, well, we ran this 400 times and the character gets to paragraph such and such 30% of the time. The character gets to paragraph such and such 5% of the time, and so on, right? It can print out, it can give me each paragraph that was visited and tell me how often particular ones were visited. And that can be very useful because we might say, oh, I thought this was meant to be just a sort of slightly obscure little side thing that's not meant to happen very often, but actually it's happening a quarter of the time or half the time. And so I might make it more difficult to get to that section. Or conversely, I might say, well, oh, this paragraph they're only getting to 5% of the time, but I put quite a lot of effort into this section, or I might have a whole series of paragraphs that they're not getting to very often that are related, linked to each other, and the characters aren't getting there very often. And I say, oh, well, I put quite a lot of effort into this particular part of the story, and I kind of had in my mind the image that maybe the characters would get there sort of a quarter or a fifth of the time, and because they're only getting there 5% of the time or whatever it is, that would allow me to look and go, okay, so what has to happen for this? And I might go, oh, I see, you need this item and you need to this and you need this. And I didn't think about how much of a filter that would be and how that would stop most characters from going to that particular place. And because that's a good bit and I like that bit and I put a lot of effort into it, well, I'm going to make it easier to get to that bit. So that's some of the things that automated testing can do. But there's a problem, which is we could set it up to, let's say we set it up to run through the program 100 times with each character and then give us the results. And we run the game, we run the program, and lo and behold, it gives us these results. how do we know that the program's sort of working properly? How do we know that it's starting at the first paragraph and going from this paragraph to 1A, which is where it's meant to be, and at 1A there's meant to be a choice which goes to 1B or H. How do we know that it's going to 1B or H? And then and so on. How do we know that at the paragraph where it's meant to be testing your luck, how do we know that that's what it's actually doing? Well, we need to have a way of running through the game automatically once, but instead of just giving us the final results, giving us everything that happens in that run through. And that is what I've done and that I'm going to talk about in today's video. So let's have a look at an example of a run through. What we have here is the computer choosing a character. There's 4 characters. In this case, it chose character 2. We get shown the skill, stamina, and luck, and we can see that the stamina is quite high. Well, no, actually, that's about normal. Sorry about that. Okay, so we can see the stats. Well, they're within the ranges that they should be, so that's good. Some of the characters have different sort of mechanical changes. Like there's one character that has a luck of 6 every time. So that's character 1. So if it said character 1 up here, we'd know to look at the luck and make sure that it was 6. And so it tells us, okay, it gives us the text of the first few paragraphs. So it seems to be doing the right thing so far. It's starting at the beginning at least. And then it has this reveal yourself, which is one of the choices. So we know that at this point there should be a choice, and one of the choices is reveal yourself and the other one is hide. In this case, the computer has chosen reveal yourself. It's randomly chosen that. All right. And what happens there is what's meant to happen when the player chooses to reveal yourself. Now, of course, in order to test any of this, we need to be familiar with the program and we need to have played it a few times. But of course, I wrote the story, and so I know that this is what's meant to happen. I know that you choose wait. Okay, they give up. That seems fine. The player lies uncomfortable through the night. Their skill is reduced by 2. That's what's meant to happen. There's a choice. You choose to weave baskets. We test skill. We seem to roll a 7. That's a success. Well, looking at our skill, we know that it started at 10 and -2, that would be 8. So a roll of a 7 should be a success, because the way that roll works is that you want to roll under or equal to the skill level. So a low roll is good, and so on, right? It's doing the things that it should be doing, and because it's doing the things it should be doing, and we'd obviously test it, run it through sort of 5 or 6 or 7 or 8 or 9 or 10 more times. But if it continues to do what it should be doing, then we can then go on to the automated testing and have confidence that it's actually giving us useful results. It's actually going through the game in the way that it should do. So let's have a look at the code that allows that to happen. So we're mostly going to be looking at this one and this one. We will be looking at this one because I haven't got it to simulate combat yet, because that is a little bit more complicated, and it's complicated enough that I wanted to give it a separate video rather than try and cram too much into one video. So we're basically going to look at this one and this one, and there's a little bit of stuff in this one. There's a couple of new variables, so let's look at those first. And they're right down the bottom. They are TZ and TY, and you can read the comments there that tell you what they are, but I'll read it out anyway. TZ is the current section, but only when we're testing. So it's equivalent to $A when we're playing the game, or when someone is playing the game. The variable A keeps track of what section they're in. When it's testing, we use TZ, and TY is which character the program has, as it were, chosen in one-off testing. So that is the equivalent to $CH. So those are the only two we need. And we also have this extra bit of code down here where we have div align equals center, which just means start a paragraph which is horizontally centered, meaning it's in the middle of the screen, not towards the left, which is the default. And we have two options, which are test or play. And if we choose play, well, that'll just be the program as we've seen it in previous videos. You choose a character and it runs you through the game. Whereas test will be the new code that generated that example of a run through of the game. So let's go to this one. This one's fairly straightforward. We set TZ equal to 1, which is the starting. TZ is the section, so we start at section 1, just as we set A to 1 in case the player wants to play it. We set TY equal to a random number between 1 and 4 because there are 4 characters, so it chooses at random. This is just the mechanical differences that come, the attribute differences basically, that two of the characters have. Character number 1 has a starting luck of 6, so he has a low starting luck, or he or she. None of the characters have an assigned gender, like there's nothing in the text that says whether they're male or female. They have a starting luck of 6, and the other one is character 2 gets an extra die roll for their stamina. They get to roll an extra die and add that number to their starting stamina. And so then we display the results. Oops, sorry. We go character $TY, so it'll say character 2 or character 3 or whatever. And then we just display the starting skill, stamina, and luck. And then we include run through. Now, run through has a lot of code. As you can see, it's very, very, very extensive. And you might say, wow, it must have taken ages to write all that, and it's going to take ages to explain all that. And you'd be wrong both times, because what I did was I went to main, mostly. I went to main, I pressed Control A, because I was using a PC. If I was using an Apple, it'd be Command A. Control A, Control C to copy. And then I went into, in my case, Notepad, although on this computer and Apple, there's a different program for working with plain text. I pasted it in there, and then I just did some search and replace. So because this section of the program uses TZ instead of A, I searched for all examples of $A, and I changed it to replace that with $TZ. And I searched for all examples of $CH, and I replaced that with $TY. And once I'd done that, I'd done most of this code. Because you remember that in main, or at least you'll remember if you've been following this series, you remember that in main most of the text, most of the code, sorry, is a series of branching based on the contents of the relevant slot of the $s array. So if $s $a1 is equal to 0, then this happens. Else if it equals 1, then this happens. Else if it equals 2, then this one happens. Else if it equals 3, then this one happens, and so on. Well, that's how it has to work in this run through as well. Except of course that it's not $s, it's not $s $a1, it's $s $tz1. Sorry, and the other thing I had to do, the other search and replace is that instead of most of these go to sorry, there we go. Most of these end with include main. In other words, go to the top of the page and sort of keep going. Well, of course, they had to be replaced with include run through, so that it doesn't. Otherwise, it would have done this one once and then gone to main, and you'd be playing the game instead of getting this automated run through. So that was the main. That was most of the changes. That was the vast majority of this code. It was just done with cut and paste. The only other thing I needed to do is to get rid of buttons that the player clicks, and those are done really in only two places. One, where we have a button that the player clicks to continue, and I think that's if the relevant number is 6. Yep, continue button. So instead of that code, if we look at main, that code prints a button, and the button has the code. The button takes you to main, and it sets A equal to what's in that slot once it's clicked. But of course, we don't want to have buttons for the player to click. We want it to just do it automatically. So in run through, we just set TZ equal to $s $tz2, which is the one that the button should go through, and we include run through. So it does it automatically without a button. The other place, of course, is in choices, and that is if that value is equal to 2, and we have this code here. So we look in slot 2, that's the number of choices. We set Z equal to a random number from 1 to the number of choices inclusive, so choose a choice without any bias towards one of the particular choices. Then we print the text for that choice so that we know, so that when we're looking at the run through, we know which choice the computer made. Then we set TZ equal to the destination for that choice, which is what that is, and then we include run through, i.e. we go to the top and keep going. And that is all of the code. Even though this is a very big page with a lot of code, it's really just basically a copy of the code that's in main, with a few search and replace, and then a couple of changes made by hand, as I've just talked about. In fact, what I probably could have done was have main and run through be the same page, and then have that page behaves differently depending on whether we were playing the game or doing a run through. And we might have a variable that keeps track of which one we're doing. So we might have, I don't know, whatever. Let's call it $MO, and $MO is 0 if we're playing the game and 1 if we're doing a run through, or something like that. And then we might, it would behave identically, except in places where there was where there were choices. So it would say if mode is 0, then that means we're playing the game. Okay, print the buttons and let the player click on one. or if it equals 1, do what's in here. But this is maybe slightly clearer, having it as two separate sections, slightly easier to explain, slightly easier to see, and certainly it will be easier to get rid of when we finish, because when we distribute this game, we're not going to have the testing stuff in there. That's just for us to make sure the game is right, is what we want it to be. It's not meant to be in the final product. So if we have it as a separate set of pages, we can just go, well, that's that one, that one, that one, oops, that one, and that one. We can just delete those three, and then the game is, we have a version of the program which is just the game, and we can distribute that version, and we can keep the testing version for ourselves, to look at in case we need to do the same thing in a different game. But anyway, so that's all we needed to do, except for combat. Combat's a bit more complicated, and I decided to treat it separately, or test. Combat in a test is a bit different. But that's how we do these one-off. Sorry, I clicked the wrong thing. That's how we do these sort of one-time run-throughs of the game, and we can look at that and we can see, good, yes, the testing does seem to be doing what it's meant to be doing. It's testing its skill when it's meant to be testing its skill, and it's making a branch based on character when it's meant to be doing that, and the branching, everything seems to be right. And because we won't, once we ensure that is true, well, then we can move on to automated testing, where we don't look at each run through in such detail. We just get the final results, and we can know that, because we've sort of because we've had this sort of closer look at one example of an automated run through, well, we know that it's doing it properly, and therefore we know that the results we're getting are meaningful. Or at least we will know that once I fix once I do the combat and make that work as well. So that's what I will be doing in my next video. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.